Hello, so this video we're looking at finding the equation of a line again given two coordinates, but we're not given the coordinates on a graph. But it's very similar to the last video. So if you watch that, this is very similar, but just this time you're not given the graph as well. So again, we want to find the equation of the line between these 2 points here. These things here, these are coordinates, okay, 0, 3 and 4, 19. And because it is a line, it's going to be in the form y is equal to mx plus c. What I would do is on this first one, I will just sketch out what is going on so we can see what is happening. And then that will just kind of give us that visual representation for the other questions. So if we were to go and kind of plot these coordinates on our x, y coordinate axes, kind of like in the previous video, so if this is our x-axis and this is our y-axis, well, the point 0, 3 is going 0 across and 3 up. It would be somewhere up here. So that's going to put that. That's going to call that point A, right? Or just let's go and call it 0, 3, so we can see it is there. And this point here, 4, 19, is going to be somewhere here. So 4 across, 19 up, so something like that. That's the point 4, 19. Okay, so these are 2 points here, and your line passes through those points. So you've got to imagine you've got a line going through those points like that. And I want to find the equation of this line. Well, if you watched the previous video, this is exactly the same thing now as what we've just been doing. Okay, but just we're not given the graph. I've just drawn it this time to make that hopefully a little bit clearer. So let's begin by finding the gradient again. Two things we've got to find with this, the gradient and the y-intercept. Let's begin with the gradient, m, where m, again, is your change in the y-coordinates over the change in x-coordinates. Well, if I begin with this coordinate first, my y-coordinate here is 19. So my y-coordinate is 19. Change, meaning take away. My other y-coordinate, which is 3. I could have started with the other coordinate and done 3, take away 19, which is fine, but then you get negative answers and you've got to deal with that at the end. So let's try and keep it easier for ourselves. And it's being divided by the change in the x-coordinates. And because I started with this coordinate first of all, let's start here again. My x-coordinate is equal to 4, and that is take away my other x-coordinate, which is equal to just 0. So 19 take away 3 is equal to 16. 4 take 0 is equal to 4. 16 divided by 4 is equal to 4. So the gradient of between these 2 points, okay, 0, 3, 4, 19, the gradient is equal to 4. Again, you could have done 3 take away 19 over 0 take away 4, because then you would have got minus 16 over minus 4, which again is equal to plus 4. It makes no difference, but I'm just trying to make it as easy as possible for myself. Good. I'm now going to go and find the c value, the y-intercept, and because I'm given a coordinate where the x value is 0, that just means the y-intercept is going to be this value here, that 3, because we can see, right, if we plot it graphically, we're going 0 across and 3 up. I cross the y-axis, which is what the y-intercept is, okay, at the point 3. So my c value is just equal to 3. So you've got to look out for that. If you have a coordinate where you're given a 0, your y-intercept is just the y-coordinate, which is 3 in this case. So c is equal to 3. There we go. Therefore, the equation of my line is going to be y is equal to m, or m is equal to 4, as we calculated, x. So again, y and x, they always just remain y and x in the equation of a straight line. They are your variables. You're changing x and y coordinates. And our c value is equal to 3. And it's plus positive, so it's going to be equal to plus 3. Okay, and that is the equation of the line that goes through the coordinates 0, 3 and 4, 19. 4x plus 3. Okay, example 2 is trickier this time, and this time I'm not going to bother sketching it out because it's the same kind of idea as the last one, but I've got a line passing through the points minus 6, minus 4, minus 3, minus 2. Let's begin by finding the gradient to begin with. So gradient, again, m is equal to the change in the y-coordinates. I'm going to begin, you can choose which ones to begin with here. I'm going to start with this coordinate first. So I'm going to do my y-coordinate here, which is 2. So 2, take away my other y-coordinate, which is negative 4, and is 2 take away minus 4. So there we go. Over the change in my x-coordinates, well, that minus 3, because I started at this coordinate, I've got to go back to it again, and that minus 3 is my x-coordinate, so minus 3. Again, change, take away my second x-coordinate, which is minus 6. So just take your time to write this bit out carefully, because it is important, this bit. So that is our m is equal to, sorry. So 2 take away minus 4, I'm at 2. If I'm taking away cold air, I'm getting warmer. So it really means 2 plus 4, which is equal to 6 over. And here, I'm at minus 3 on my number line. I'm at minus 3. If I'm taking away cold air, I'm getting warmer. So warmer by 6, so I'm adding on 6. So it's going up to positive 3. Minus 3, add 6 is 3. So 3 goes down here. So 6 divided by 3 is equal to 2. So that is the gradient of my line. Okay, and I've still got to find the c value, the y-intercept, which is trickier this time because I'm not given a coordinate where the x value is 0. So like on the previous video, I've got to use my equation of a line, which is y is equal to mx plus c, and use my gradient, m is equal to 2, and choose a coordinate to substitute in to get a y and an x coordinate to find my c value. Probably choose one which is going to have slightly easier numbers, which is probably minus 3, 2, because I've got one positive number, but it is a choice. You could use any coordinate. I've just chosen this one here. So that minus 3, that is an x coordinate, and that 2 is a y coordinate. So now I've got a y coordinate, which is 2, an m value, which is 2, an x coordinate, which is equal to minus 3. I just substitute it all into this to find my value c. So y is equal to 2. So 2 is equal to m, which is also 2. X is equal to minus 3 plus my c value. So 2 is equal to 2 times by minus 3 is minus 6. Add my c value. So solving an equation to find c here, I want to get rid of that minus 6. I can add on 6 to both sides. Add 6, because then what happens here? These cancel, and I'm left with just a c, which is good. That's what I'm trying to find. And 2 add 6 is equal to 8. So my c value is equal to 8, which I could write the other way around as c is equal to 8. They mean exactly the same thing. And check it, is minus 6 add 8 2? It is. Good. So my c value is equal to 8, which is good. Therefore, the equation of my line is going to be, well, y is equal to my m value. M is equal to 2. So 2x, my c value is 8 and it's positive, so plus 8. So that is the equation of my line that passes through the coordinates minus 6, minus 4, and minus 3, 2. Okay, question 3, or example 3, before we get on to the 2 questions you can try yourself, is in a slightly different format, but nothing that we can't handle. It's just being able to make sure we can interpret what the question is saying. So find the equation of the line that has a gradient of a half. So it tells us that the gradient, which is m, is equal to a half. So we can write down straight away that m is equal to 1 over 2. So they calculate it for us already and passes through the point 4, 5. So really now, this is the same question as what we've just been doing, just kind of almost easier because they tell you the gradient and they give you a coordinate, which is 4, 5, which the 4 being your x coordinate and the 5 being your y coordinate. And we're putting it into the equation of a line, which is y is equal to mx plus c. So I'm trying to find the missing c variable. My y coordinate is 5, so I get 5 is equal to m. M is a half, so 1 over 2. My x coordinate is equal to 4, so half times 4 plus c. So 5 is equal to half of 4 is 2 plus c. 2 add what is equal to 5? 2 add 3, so c is equal to 3. So I know my gradient is equal to a half. That was given to me in the question, which is nice. And I calculated my c value to be equal to 3. Therefore, the equation of my line is going to be y is equal to my m value, which is equal to a half, given to us in the question, so a half x, plus my c value, which is positive 3, so plus 3. And that is my answer in this question. Good. So now you can pause the video, give those 3 questions a try. If you could go through all the examples, this is the same stuff, but just ones that you can try yourself. And you can fast forward to the end to see the answers. So question 1, let's begin. Find the equation of the line that passes through the points minus 8, minus 10, and 0, 14. And again, it is a line, so it's going to be in the form y is equal to mx plus c, where I want to find the m value and the c value. So again, let's begin by finding the gradient m, which we know is equal to the change in the y coordinates, so change in y, which we can write like this, over the change in the x coordinates. This just means, again, the same thing as change in y. That triangle means change in x. That triangle means change in x. It means the same thing, just a short way of writing it. And let's begin with this coordinate to start with. It doesn't matter, you could start here, but I'm going to start here because why not? My y coordinate here is 14, so 14, take away my other y coordinate, which is negative 10, over, change in x, because I started it, I've got to start here again. My x coordinate is 0, take away my other x coordinate, minus 8. 14 take away minus 10 means 14 plus 10, which is 24, over 0 take away minus 8 means 0 plus 8, which is equal to 8. 24 divided by 8 is equal to 3. So my gradient here, m, is equal to 3. So I found m. I'm going to go and find my c value now. And note here, and this is important, that I've been given an x-coordinate of 0, which just means my c value, my y-intercept, is going to be equal to 14. And I'll show you again by sketching it, because that might be useful, but hopefully we know that from the first example, but if I sketch it out, right, the coordinate minus 8, minus 10 is going to be somewhere down here. That is the point minus 8, minus 10. This coordinate 0, 14 is going to be somewhere on the y-axis, okay, because we're going 0 across and 14 up, so 0 and 14. Your line goes through both of those points like that. Well, the c value, the y-intercept, is this point here, which is got the y-coordinate of 14, not 4, sorry, I should say 14 on there. Sorry, pen. 14. Okay, so my c value is just equal to 14 because my x coordinate is equal to 0. So there is my c value, just 14. Good. Therefore, the equation of my line is just going to be y is equal to m, or m is equal to 3. So 3x, my c value is equal to positive 14. So 3x add 14, that is the equation of my line that goes through the coordinates minus 8, minus 10, 0, 14. Good. Question 2. Let's move on to it. A bit trickier because this time we're not given a coordinate with an x coordinate being 0, but nothing that we can't handle. So again, let's begin by finding the gradients of the two coordinates. So m is equal to the change in the y. Again, let's write it out. So change in the y over change in the x. If I begin with this coordinate here, because why not? You could again start over here. It makes no difference. I'm going to start here though. Well, my y coordinate here is 7. So 7 take away my other y coordinate, which is 2, over my change in x. So 1 take away, because change, my x coordinate is minus 4. So I've got 7 take away 2 is 5 over 1 take away negative 4 means 1 plus 4, which is 5. 5 divided by 5 is equal to 1. So my gradient between those two coordinates is equal to 1. Good. I've got to go and find my c value still. I've got m. And this time I can't just go and read off my coordinates because none of the x coordinates are 0. So I've got to use a bit of substitution. So I know my equation of a line is y is equal to mx plus c. I know the m value is equal to 1. And I choose a coordinate that I can put into my equation to find c. And you want to use the one which is going to give you easier numbers, so probably 1, 7 is a good one to go for because everything is positive. So y, where again that's my x coordinate and that is my y coordinate. So y is equal to 7, so 7 is equal to m is equal to 1, so 1, and x is equal to also 1, so 1 times 1 plus c. So 7 is equal to 1 times 1 is equal to 1 plus c. So 1 add what is 7, 1 add 6, so my c value must be equal to 6, and that is my y-intercept, my c value. Therefore, the equation of my line is going to be y is equal to my m value, which is equal to, m is equal to 1, so 1x. 1x you can write just as x, it means the same thing, more simplified, so just x, which means 1x, and my c value is equal to 6, so plus 6. So y is equal to x plus 6, that is my answer. There we go. Good. And then last but not least, we've got find the equation of the line that has a gradient of minus 2/3. So it tells you that the gradient, which is the m part, so m is equal to minus 2 over 3, and passes through the point 9, 15. So it goes through the coordinate 9, 15. So this time, a bit of a different format of a question, but stuff that we've done before now. So we know that the equation of a line is going to be y is equal to mx plus c, where this 9 is my x coordinate, that 15 is my y coordinate, and I just go and put everything into my equation to find c. So my y coordinate here is 15, so 15 is equal to my m value, m is equal to minus 2 over 3, so minus 2/3. My x coordinate is equal to 9. My C value I'm trying to find, so plus C. So 15 is equal to minus 2/3 times by 9. Okay, this bit here, if we want to look at it without using a calculator, it just means we've got minus 2/3, and we're timesing it by 9. 9 you can write as 9/1, because it just means 9 still, 9 divided by 1 is 9. Minus 2 times 9 is minus 18 over 3 times 1, which is 3. 18 divided by 3 is 6, but it's minus, so minus 6. So minus 2/3 times 9 is minus 6 plus C. So minus 6 add what is 15, C must be 21, because minus 6 add 21, or 21 take away 6 is 15. If you want to see that in more detail, solving an equation, add 6 to both sides, because then what happens over here? These two, they cancel, which is good. And we get 15 and 6, which is 21, is equal to our C value. So C is 21. There we go. So almost there now, just got to write it in the correct form. So I know my gradient is minus 2/3, and the equation's got to be in the form y equals to mx plus c. So y is going to be equal to my m value, which is minus 2/3, x, my c value is plus 21. And that is it. Okay, so y is equal to minus 2/3, x plus 21. Right, so if you fast forward to the end of the video and you got all of those correct, that is fantastic, because, yeah, just something else that you can do in your inventory, which is brilliant. I think we're going to have one more video on equations of straight lines, and that will be it. Thank you.